Hello and welcome to the JTWizard tutorial video. My name is Amir Al-Ansari and I'm the creator of JTWizard. JTWizard is an Excel-based jar testing companion that is meant to guide you through the entire jar test process and make the whole thing easy, straightforward, and efficient to do. In this video, I'll show you how to use the tool and demonstrate some of JTWizard's capabilities. We created another video that focuses on the theory of jar testing, and we show you in that video how to actually perform a jar test, so I would recommend watching that first if you haven't already done so. JTWizard always starts on the main tab, which basically has two things you can interact with. This button launches the JTWizard tool, and below is the results summary section. JTWizard is in fact more than just a guided jar testing tool. It actually stores all the experimental parameters as well as the results from your experiment in an organized and convenient location. So whether you perform jar tests regularly or on an as-needed basis, you always have access to your data from here. All the data is stored in the results tab, but I'm going to leave that for the end. I put this results summary section here so you can quickly access your 10 most recent jar tests and visualize the results with the touch of a button. So this box right here is an XY chart that plots the final turbidity versus coagulant dose or pH, depending on what you select under chart controls over here. Constant pH means that the coagulant dose is varied as the pH is held constant, and constant dose is just the other way around. So when you click on one of these options, the program searches through the entire records and lists the 10 most recent experiments below. For example, we see that I have one experiment that was performed under constant dose mode, and if I select constant pH, we see that I have 3 experiments performed under constant pH. I can select or deselect these checkboxes to compare the experiments directly to each other, or use that as a starting point for my next experiment. So we will begin now by clicking on this button over here, and the first thing that it will do is ask you if you want to run the wizard in the water treatment plant or research lab mode. Both procedures are about 95% identical, and the only difference between them is that with the research lab mode, you have a little more flexibility with the jar test procedure and the volume that it's using in the titration process. I'm going to select water treatment plant mode since this tool was mainly created for water treatment plant operators. After we select the mode, we are presented with a list of all the saved jar test procedures. Essentially, the procedures have information that would be common between your jar test experiments. For example, the number of mixing stages or the number of beakers or stir your jar tester has. These two procedures right here come by default with JTWizard. The top one is the standard jar test procedure that we developed at UNC Charlotte and is the one that's used in the jar testing video. The second one is a procedure developed by Charles King, which is basically a 10-minute jar test procedure. You can learn more about the quick procedure by referring to his thesis. Although I would recommend starting with the standard jar test procedure to establish some baseline values before actually trying the quick procedure. You can also create your own procedure by clicking this button down here, and this will launch the jar test procedure setup form. When you click on any of the saved procedures, a few more buttons become visible. You can view or edit a procedure, delete the procedure, and of course perform a jar test using the selected procedure. If you accidentally delete the default procedures, you can simply download another copy of JTWizard. Instead of creating a new procedure, I'm just going to make a copy of this existing standard procedure by clicking on this View/Edit button. You get the same window that appears when you click on the Create a New Procedure button, but all the boxes are populated by the values from the saved procedure. You can start by naming your procedure and entering the name of the person creating the procedure. So I'm just going to call this one Standard Jar Test-Copy and click Next to go to the next page. Here you specify the type of jar tester you have, and you select whether you have a programmable or non-programmable jar tester. Also, you select the number of beakers and stirs your jar tester has. JTWizard was essentially created for the Phipps and Bird jar tester, so you may or may not run into issues if you are using something else. A critical part of the setup is a beaker with a sample port. You can use our standard jar test procedure without a beaker with a sample port, and it will become apparent why in a minute. So I would highly recommend getting or even making some if you don't have any. Clicking next will take us to the mixing program page. Here you can add up to 5 mixing stages, even though the programmable Phipps and Bird only has 4. Text boxes appear corresponding to the number of stages that you select over here. If you hover your pointer over pretty much anything in JTWizard, you'll get this tip that explains what the item is and the type of input that it is expecting. For example, we see here that it is expecting positive whole numbers between 5 and 300. Even without knowing that, you're actually limited to what it expects you to enter in that text box. Pay attention to the on-screen keyboard on the bottom right corner of the screen. Notice how when I try to enter text, nothing really happens. Also, since it's expecting a positive number if I try to enter negative or the negative sign, you see that nothing happens either. It's also expecting a whole number. So let's say I wanted my RPM to be 30.4, and it lets me type the 3 and 0, but no decimal points. Finally, since it's expecting the value to be between 5 and 300, if I try to add a 9 to make the RPM value be 309, we see that the value automatically changes to the max value, and if I enter something below 5, we see that it again automatically corrects that value and sets it to the minimum. So now I'll just change this back to 30 RPM. And for the duration, we see that it's expecting values in increments of 0.5 minutes or 30 seconds. So what would happen here is that it will round up or down depending on the number you enter. So if I enter 10.2, we see that it rounds it down to 10. And if I enter 10.7, we see that it rounds it up to 11. But it accepts my entry if I enter 10.5. And last, before proceeding to the next page, the program checks all the entries and makes sure that they are all valid. So I'm going to change my duration back to 10 and press next to go to the next page. Here you have the particle separation stage. You can immediately see why you absolutely have to have beakers with a sample port. Our procedure uses filtration instead of settling for optimization. This is more comparable to what's actually happening in the full-scale process. And all of the theory behind this stuff is discussed in the jar testing video. You actually have a little bit more flexibility with this stage if you're using JTWizard under the research lab mode. Next, we need to specify the type and properties of the coagulant you are using. So here we have a list of common coagulants used in the United States. So once we select the type of coagulant we're using, we specify the molecular weight of the coagulant, its specific gravity, and the concentration. Once you enter the concentration, you select the concentration unit and specify the form in which the concentration is reported. And this is typically found in the coagulant's MSDS. This drop-down menu is linked to the coagulant type selected in this menu here. So if I change this to ferric chloride, you see that the list changes to match the coagulant type. On the last and final page, we have the option to include a polymer in the jar test process. So if I select yes, I have the option to select my polymer type, enter a name for the polymer and its concentration. But for now, I'm just going to turn this off. So I can either close the user form without saving or finish and save. And I'm going to click finish and save this procedure. At the end of each experiment, JTWizard generates a one-page PDF summary report. So we need to specify a location where that report is going to be saved. So I'm going to click on this browse button over here. And then I'm going to create a new folder. And I'm going to call this jar test results. And then you click OK. And you only need to do this once because your preferences are automatically saved. And now we're ready to start the jar test procedure. So to begin, I'm going to select the jar test procedure that we just created and then click on Perform Jar Test. After selecting the jar test procedure, you get this user form right here, and up here you can see that the procedure that you are currently using. To start, we need to select which variable we are holding constant and which one we are investigating. The parameters displayed in step 2 will change depending on the options you select. For example, right now I'm on the constant pH and varying dose mode, so down here I see that it's asking for the target pH of my experiment. And if I select coagulant only, no pH control, we see that since I'm not controlling pH, this target text box disappears. The type and concentration of the stock coagulant solution are pulled from the procedure that I selected. So remember that we use 48.5% as aluminum sulfate-14H2O when we created our procedure. JTWizard already calculated that concentration in terms of milligrams per liter as aluminum. It's always best to report your coagulant concentration in terms of its metal content. That way, regardless of what form your coagulant concentration is in, you're always adding the same amount of the active ingredient to the water, and in this case, our active ingredient is aluminum. I can also change the type of coagulant I'm using in this experiment. So if I change this to ferric chloride, for instance, you see that the units change to match the coagulant that I'm using. However, one drawback to doing this here is that I would need to manually enter the as metal concentration of my coagulant. Of course, it's always easier to just go back and edit it in the saved procedure. So I'm just going to change this back to aluminum sulfate and continue with the setup of the experiment. So I'll select constant pH varying dose, and I'll just leave this target pH at 6.5. And since we're varying the dose, you can see that down here we have text boxes where we can enter the concentration of the coagulant in each jar. You can enter the coagulant dose in whatever concentration you prefer using, and JTWizard will automatically do the conversion for you. So if I typically use milligrams per liter as whatever stock solution I'm using, in this case it's aluminum sulfate-14H2O, then we see that JTWizard automatically converts that to milligram per liter as aluminum equivalent. I'm going to leave the coagulant dose at the default unit and enter the values for my experiment. And that's 30 for the first jar, 35, 40, 50, 70, and 100. And I'm sure you're wondering what this warning button in the bottom is, so I'm going to click that and see what the warning is about. So here it's telling me that the volume of the coagulant that is needed for the lowest concentration I have, in this case it's 30 milligrams per liter, is too low. So you see that I would need to add about 0.1 mils if I wanted to use the stock solution. So what it is basically recommending is diluting the coagulant in order to increase the volume that you would need to add to achieve the concentration in that jar. So it's basically looking at how much you would need to dilute the stock in order to add at least 1 ml of coagulant solution. However, it would only dilute the coagulant down to about 800 milligrams per liter because the coagulant becomes unstable below those concentrations. And therefore, you might run into some volume issues if your concentration is too low relative to your coagulant concentration. And as you can see here, it's recommending that we dilute the coagulant down to about 5,460 milligrams per liter as aluminum, and it's giving me instructions on how to do that. And I'm going to apply this dilution by clicking this button here, and we see that it automatically updated the stock coagulant concentration. Now if I select varying pH and constant dose, we see that the target pH text box changes to target dose, and my jar test variables change to pH. And therefore I would just need to enter the dose that is being held constant in all of the jars. I also get this unit conversion tool button, and I can convert my coagulant concentration in whatever units, such as aluminum sulfate-14H2O to milligrams per liter as aluminum, and just enter that number in my target text box. So I'm going to go back to constant pH and varying dose and re-enter my coagulant concentrations and go to the next page. On this page, we prepared the jar tester for our experiment. We see that we're going to fill each beaker with 2,000 milliliters of water. Next, we enter the temperature of the water, and we see that the G values are automatically calculated at that temperature. If you wanted to, you can even change the RPM to hit any G value target you want. However, I would recommend just leaving the RPM at the default values. I can also edit the duration of each stage. If you recall from the jar test procedure setup, the last stage was 10 minutes, but here it's telling me to program it to run for 16 minutes, and I'm going to click on this note right here to see why that is. So since I'm going to be filtering my water at the end, I'm adding the time it takes to filter my samples to the final stage. It doesn't matter what time I add to the final stage, so let's say I want my final stage to be 20 minutes instead of 10, we see that the time that is required for filtration is automatically accounted for and added to the final stage. Finally, we have an estimate of the approximate total experiment runtime. This is of course without the titration stage. And now we'll move on to the next page. Here I need to enter the water quality characteristics of my raw water, and these are just some of the relevant parameters in jar testing. This is optional and you don't need to enter anything to proceed, but I highly recommend that you measure and record the water quality characteristics each time you perform a new jar test. And this will allow you to see how your optimum conditions change with your water. So I'm going to enter values for my alkalinity, hardness, and turbidity. And there's a note over here about turbidity, so I'm going to click on that. And basically it's just saying that you should record your turbidity 30 seconds after you insert your sample into the turbidimeter. This is more for consistency than anything else, so if you use 45 seconds or 1 minute, it's fine as long as you're consistent between your samples. I also have the option to include up to 3 optional parameters. For example, I may be interested in my organics, so I can include DOC and UV254 and enter raw water quality values for those. The next step in the process is the titration stage. If you're not controlling the pH, you won't see this page. Up here we have the volume of the water that we're going to be using in the titration process, and it's going to be 2000 milliliters in the water treatment plant mode and 200 mL in the research lab mode. This box here guides you through the entire titration process. We always start with measuring the raw water pH. Next, we add the volume of coagulant that corresponds to the concentration we specified in step 1 and then record the pH of the water. Remember to always remove the electrode before adding the coagulant. Based on the pH after adding the coagulant, JTWizard determines whether I need to add acid or base to hit my target pH. In this case, because the target is above 6.5, I would need to add acid. In order to keep track of how much acid or base I'm adding during the titration process, I can use the titrant volume tracking tool. So let's say we start with 0.1 mils. I just enter that here, then I click add, and over here you can see that the total volume that I added to the beaker is 0.1. Let's say that 0.1 barely moved the pH and I decided to increase the volume to 0.4. So I enter 0.4, and again we see that the total volume changed to 0.5 mils. Once I hit my target pH, in this case using 1 mils, I record the total volume of acid or base I added in step 5 over here. Next, I click on jar 2 and repeat the same process, and I'm just going to quickly enter these numbers since I already did this experiment. So here you see that since my pH after coagulation is lower than my target pH, it's telling me to add base in order to increase the pH to 6.5. Once I'm done with all the jars, I click next to go to the next and final step before starting the experiment. We first start by filling the syringes with the volume of coagulant corresponding to the concentration we selected in the first page. For instructions on filling the syringes, simply click on this syringe filling guide. Next, we add the volume of the pH adjusting chemicals that we determined from the titration step to each jar. And finally, we want to make sure that we actually hit our target pH, and therefore at the end of the rapid mix stage, we have to collect samples from each jar and measure the pH. And now we're ready to begin the jar test. So to start, I simply click on this button over here, and I get a 15-second countdown timer to start the experiment. At the end of this timer, I'm supposed to press start on my jar tester, and at the same time, dose all of my coagulant into the jars. The Windows beep sound signals the start of a new stage. You will hear this sound every time JTWizard starts a new stage. Once the experiment begins, you get a total elapsed timer here on the left and a time to the next stage here on the right. In the middle, you have your experiment progress indicators. And finally, in the bottom, you have your results log where you can enter your results for pH, final turbidity, and values for your optional parameters. At the end of the first stage, I need to collect samples to measure the post-coagulation pH. So I collect samples from each jar and I just enter the values in the text boxes. And since I already did this experiment, I'm going to enter those values right now. I'm going to pause the video here and come back when the last stage is about to finish to talk about what happens during filtration. Okay, so we're about 5 seconds away from the end of the final stage, and it should start the filtration stage shortly. And there we go. So this is the filtration stage, and as you can see, the progress indicators change to the individual jar timers. Below the progress indicators, you have these labels that essentially tell you when to open the valve to start filtration and when to collect your turbidity samples. Basically, you have a 30 seconds offset between the jars. So after opening the valve on jar 1, you wait 30 seconds and then open the valve on jar 2. And I'm going to fast forward this part of the video again. Okay, so we're almost done with the last jar. And once the experiment is over, the status button will change from filtration to experiment complete. And before I click on finish to complete the experiment, I'm going to enter my jar test results here. And then I'm going to click on finish, and the first thing that JTWizard will do is copy the results to the results sheet and then generate the report that it will save to the folder that you specified earlier. So here's the report. On top you have a summary of the experiment details such as coagulant dose, the control variable, and the procedure used. And then you have your raw water quality results, and then finally your jar test results. So you have your jar test results table that shows you the coagulant dose, post-coagulant pH, and then the final turbidity in each jar. The main feature of the report is this results plot. On the primary y-axis, you have the chemical cost to treat 1 million gallons of water. Basically, I took the average US costs of alum, sodium hydroxide, and sulfuric acid, and then used the amount of chemicals that was used in the jar test and scaled it up to an equivalent amount that would be needed to treat 1 million gallons. Now, these numbers might not necessarily be accurate, but they are certainly relative, which means you can expect the chemical cost to change by approximately the same factor as shown by these bars. And on the secondary y-axis, we have turbidity that is represented by the line plot. If we look at the caption, we see that some of the jars were labeled with symbols. So the asterisk shows the cheapest treatment option and the double dagger shows the best treatment option. The cheapest treatment option is straightforward. The algorithm simply picks the jar with the lowest cost that has a final turbidity below 0.3 NTU. For the best treatment option, the algorithm first excludes the jars that are above 0.3 NTU. Next, it sorts the jar based on ascending turbidity, that is, from the lowest to the highest turbidity. Next, it excludes the jars that are greater than 0.05 NTU of the lowest turbidity. And finally, it sorts the jars based on the cost, and it selects the cheapest jar as the optimum. The last thing we have is this results quality check. We see that we get a warning for the turbidity. This is because the turbidity in one of the jars was above 0.3 NTU. And if we look back up to the results table, we see that yes, the turbidity in jar 5 was 0.517. JTWizard is also checking that the post-coagulation pH is within an acceptable range of your target pH. Basically, anything within plus or minus 0.2 pH units is acceptable. And as we can see from the results, that's true. And that's it for the report. I'm going to close this and we'll continue to the results sheet. Here in the results tab, we see that my experiment was added to the end of the table. Right now, I'm in the simple view mode. In this view, I'm getting the most relevant information without having to sort through everything. So if I want to view everything, I simply click on complete view, and now I can see everything that was exported by JTWizard. And I'm gonna go back to simple view now. Now everything in this sheet is protected. So if I try to make any changes, you see I get this message. The only place I can make any change is this yellow legal pad color area. However, even in that cell, I am limited to what I can do. So let's say that the raw water turbidity of my experiment was actually 45. So I'll just click on that cell, and as you can see, it allows me to edit it. And I'm just going to change the value to 45, and as soon as I make that change, I get a little red indicator on the top right corner of the cell. So this is a comment, and when I move my mouse over the cell, I can make that comment appear and see that the cell was edited on this day and this time, and that the original value was actually 50. So what if I try to go back to the original value? Well, I can't undo anything on this sheet, so I'll just try to press Ctrl Z, and you can see nothing happens. So what if I enter the original value of 50 again? Again, we see that the red indicator is still there, and it simply adds another line to the comment for the value that was changed. You can even delete the cell in the value, and it still retains all the values entered in that cell. If you wanted to do more with the data or export it to another sheet, you can simply select the columns or cells that you want, and just copy and paste it into a new spreadsheet. Now, the only other thing that I can do is delete an entire column. So as my selection moves to different columns, we see that the red button on top that allows you to delete the entire column moves to the column that you are selected. So I'm just going to delete this column. So I'm going to push that button, and then it's going to ask me if I want to delete it, and I'm just going to select yes, and the column is permanently deleted. So that concludes this tutorial of JTWizard. I tried to cover everything that you would need in order to start using JTWizard, but if you run into any issues or have any questions, please don't hesitate to contact me. Thank you for watching this video, and good luck with all your jar tests.